feasibility test of octagon lifter with a position sensor. The position sensor is not wired to anything, but it's a feasibility test to see if it can be lifted. And well, you know, the sensor can be lifted, so that is good. So next step will be to put some wires on it and then write a program. That's a lifter kind of flying with wires. So I think that having wires on the sensor is possible. It is possible, I think. They just have to be very, very thin wires. They just have to be thin wires. This is the software for a closed loop feedback control system for an ion lifter. This is written in jQuery. It's web browser based, uses WebSockets. This is the server. It's an ESP32. Basically, it creates a network. This is obviously the ion lifter inverter. That's a 2-channel inverter. This will be networked. This is an Xbox 360 control pad, so this will be used for controlling the lifter. So let's enable it. I mean, you can use it two ways. You can either use it with the Xbox control pad, or you can just use sliders. So the thruster will be the trigger. The controls are going to be similar to Grand Theft Auto driving controls. Yep, so there we go, that's the joypad. As you can see, you've got MPU 6050 Euler angles. Here is the MPU 6050. That's the actual sensor right there. Shift it around. It's using thin magnet wire, so that's going to be attached directly to the lifter. It's going to be using a separate power supply because you do not want to be wiring this to a computer with high voltage, not via USB. This is an alternative octagon lifter, untested, but you know, I'm going to be testing that pretty soon with the position sensor on it. So shift the position sensor around using Madgwick and Mahoney controls. So watch this space. This will be the ion lifter feedback control system.